Okay, in this video, we'll begin to take a look at Chapter 3, Section 1, Graphing Linear Equations with Two Unknowns. And there's three things that we need to be able to accomplish through this section. Number one, we want to be able to graph an equation in two variables. First of all, that is to graph an equation that is in what we call slope-intercept form. So number one, slope-intercept form, which is y equals mx plus b, where m is our slope and b is our y-intercept. Then we need to be able to graph an equation using the x and y intercepts, and usually these equations are written in what is called standard form. And in standard form, we have a number times x plus a number times y is equal to a constant. And then finally, we need to be able to graph horizontal and vertical lines. So a horizontal line has the form y equals some number, a, b. Y equals 2, y equals 4, y equals -3, etc. Now, students have a lot of trouble with this because they think y equals 3 is the answer to an equation. It's just a number. But y equals 3 is an equation. When we're graphing, it is a horizontal line. It's a horizontal line where all the points have a y-coordinate of 3 or -2, or all the y-coordinates have all the points have a y-coordinate of 4, etc. Then we have another, which is a vertical line, and that's where x is equal to some number. And so x equals a number, means we have a vertical line where all of the x coordinates of all of the points have the same value. And when we graph those points, we'll see a vertical line come out from that. So these are the three things that we need to be able to accomplish in this particular section. So let's get started. We'll graph equations in slope-intercept form and take a look at what we need to do with them. All right, so the first example, we want to graph the equation y is equal to -3x plus 2. Well, when we're graphing equations that are in slope-intercept form, the first thing that we want to do is to plot the y-intercept. What is the y-intercept? The y-intercept is the point where the graph crosses the y-axis. And you remember that when we have the slope-intercept form, y equals m times x plus b, then b is the y-intercept. That's the y value where the graph crosses the y-axis. So in this case, our y value is 2. And so the first thing that we would do is put a point on the y-axis at y equals 2. Then the second thing that we're going to do is to use the slope to plot additional points. Now again, remember that in y equals mx plus b, m is the slope. So here our slope is -3. Now what does that mean? That means if you are not sure what slope is change in y over change in x, which means, and when you have a -3, it really means -3 over 1. So what that means, the negative means that we're going down here. From left to right, the line is going down. So the way we're going to do this is we're going to go down 3 steps and right 1. So a slope of -3 means from the first point that we plot, we're going to move down 3, right 1. We're always moving from left to right, down 3, right 1. Now at a certain point we run out of space, so we can also go in exactly the opposite direction, which would be up 3, left 1. And there you can see what this line is going to look like. And so we draw the line through those points, and that is the graph of y equals negative 3x plus 2. So let's repeat the steps again. We're going to plot the y-intercept. That's the number that's added on to whatever is multiplied times x. And if it's positive, it's going to be positive 2. If it were negative, it would be negative 2. And from there, we use the slope. If the slope is a whole number, we can always translate that into the whole number over 1. If it's positive, we move up and right 1. If it is negative, we move down and right 1. If we don't have any more room on the screen or on the graph, we can do in exactly the opposite way. We can, if instead of going down 3, right 1, we can go up 3, left 1. Instead of going up 2, right 1, we can go down 2, left 1. All right, so let's take a look at another example here. And so here we want to graph the equation y is equal to negative 4x plus 2. Once again, what do? We start with the y-intercept. The plus 2 is the y-intercept, and the negative 4 is the slope. Remember, slope is when you have a whole number, you can always interpret that as being over 1. Any number divided by 1 is itself. So negative 4 means we're going to go down 4. We take 4 steps. So that would be 1, 2, 3, 4 steps. Then we're going to go right 1. We always move from left to right, and we would put our point there. Now I'm going to erase those steps. It's not 4. You don't go down 4. You don't start counting from the row that you're on. So you have to take the steps. You're going to take 4 steps down, 1 step to the right. And then from that point, we can go down 1, 2, 3, 4 steps again, 1 step to the right. If we want more points, we can go in exactly the opposite direction, up 1, 2, 3, 4, and over and left 1. And so you can see that all of those points lie on the same line. All we have to do now is draw a straight line through the points. And so that is the graph of y is equal to negative 4x plus 2. All right, so this is an example of how we're going to go about graphing equations that are in slope-intercept form. Now we haven't looked at an example of where our slope is a fraction. When you have a fraction such as m is equal to 2 over 3, then that would be up 2, right 3. We always move from left to right. M is equal to, if m were equal to negative 4 over 5, we would go down 4, right 5. And remember, if you run out of room, you can always do exactly the opposite. In the first case, instead of going up 2, right 3, we could go down 2, left 3. So either way would be correct. Down 2, left 3. But you can't mix them up. Instead of down 4, right 5, we can go up 4, left 5. So either way would be okay. So if you're dealing with a slope that is a fraction, the numerator tells you your change in y, your vertical motion. Positive moves up, negative moves down. And your denominator is your horizontal motion. We'll always move to the right, except when we run out of space, then we will do the exact opposite. Instead of down and right, we will go up and left. Or instead of up and right, we will go down and left. All right, in the next problem, what we're going to look at is graphing with x and y intercepts. And I will stop this video at this point, and you should go ahead and practice some of the homework exercises that are either in the back of the book or in your homework sheet.